everyone. This is Sravana, working as assistant professor in EC department. My today's topic is minimum mode and maximum mode of 8086. So actually, what is a minimum mode and what is a maximum mode of an 8086? So 8086 works in two modes: minimum mode and maximum mode. What is a minimum mode? Minimum mode is if you are connecting a one-to-one processor, then it is called as a minimum mode. What is a maximum mode is when if you are connecting to the processor more than one device or more than one processor. If you are connecting to the main processor, then it is called as a maximum mode. So 8086 has one special. It is one kind of speciality where it can work in two modes: minimum mode and maximum mode. So now let us go through what is how the minimum mode is function and how maximum mode is function. So here, as we know, a minimum mode. This is a minimum mode which is connected. In this minimum mode, here we have a clock generator which generates a clock frequency for an 8086. That IC number is 8284. 8284 gives you a clock frequency for 10 megahertz, 8 megahertz and 15 megahertz for 8086 microprocessor with the crystal oscillator. It is used to generate the frequency by using a crystal oscillator. Though the input pins for this are a ready and reset. The output pins for the clock generator are clock pin, the reset pin and the ready pin. These are the three output pins which are connected to the 8086 microprocessor. Now I need to work my microprocessor in a minimum mode. So what are the pins which comes into consideration whenever you are working in the minimum mode and maximum mode? So see here we have a minimum Mn by Mx bar. The pin which decides the processor whether to work in a minimum mode or maximum mode is Mn by Mx bar. So as we can see, Mx is an active low pin and Mn is an active high pin. Whenever this pin is equal to 0, it means you are working in the maximum mode. And whenever it is equal to 1, it means that you are working in a minimum mode. So this is the only pin which decides whether you are working in a minimum mode or maximum mode. So if I need to work in the maximum mode, I need to connect this to 0. So you can see 0 can be connected to the ground. And if I need to work in the maximum mode, the pin need to connect to the ground, and minimum mode, the pin should be connected to the VCC. So VCC voltage which gives you a 5 volts. So this is the only pin which decides. And here I am in minimum mode and maximum mode. We are saying we are connecting an external processor to my main processor. So when does the point comes into a picture is when you are working with the memory operations, or whenever you are working with the outside processor which is connected to the 8086. So you can say memory or IO mode. So IO mode is nothing but what? If you're connecting an external processor to the main processor, that means you're connecting an external IO to the 8086. If you are working in the memory mode, that is nothing but the memory which is assigned to 8086, 1 MB memory or the general purpose. If you are working with the memory related operations with the 8086, then it is called as a memory operation. So that is decided by Mn by IO bar. So this, as you know, whenever a bar is connected, it means you are working in the active low. That pin works in the active low. IO is input and output. Whenever this pin is equal to ground, then that means you are working in IO mode. Whenever this pin is connected to VCC is nothing but 5 volts, then it is called as a memory operation. So this pin decides you whether you are working with memory or IO. Next, whenever you are working with an interrupt IO modes, or IOs are nothing but the external input output devices. Whenever you are working with input output devices, those are worked with the 8086 in terms of interrupts. So you need to make sure whether you have got an interrupt acknowledgement or not. The interrupt acknowledgement will be activated when the external processor are connected to the main processor. Then interrupt acknowledgement will be enabled. Next, RD and WR. RD is nothing but read operation and WR is nothing but write operation. These both are active low pins. Active low pins means whenever it is equal to 0, then only it works. Next, DEN bar. What is a DEN bar? Data enable. Data enable. If the data is present on the data bus, then this pin is equal to 0. Why? Because it is an active low pin. Next, whenever the data is not present on the data bus, it means data enable pin is equal to high. ALE. What is an ALE is nothing but address latch enable. As we know, we have multiplexed address and data lines which are combined, and only it is working as a single bus. If I need to separate the address with respect to data, then address will ALE pin will be used. Next, DT by R bar and BHE, bus high enable, and DT by R bar is data transmit and data receive. As you're going for read and write operation, you use data transmission and data reception. So for this 8086 microprocessor, here as we are working in the minimum mode, this MN by MX bar is connected to VCC, and M by IO bar is taken out because if I need to connect any IO device, I can connect to this. And interrupt acknowledgement is another pin which is taken as external pin. And for read operation and write operation, we are connecting that pins to the IO device which is connected to the processor and RAM and ROM. As we know, every processor will have a RAM as well as a ROM. So data will be present in that. If I need to get the data, I need to read the data. After processing that, I need to write the data into that memory location, either it may be a RAM or ROM. So read and write signals are always connected to the memory devices and the IO devices where I need to send the data and receive the data after processing in the microprocessor. So you see, read pin and write pin are connected to both RAM and EEPROM and as well as IO device. And next, the data enable, address latch enable, bus high enable is taken out, and data transmit and receive is directed by using a trans receiver. So trans receiver shows you how the direction of the data is transmitted. Either it is transmitted from either it is done for transmission or either it is done for the reception. That can be the direction of that is given by DT by R bar to this trans receiver. So trans receiver decides which data which is connected to it, either the RAM or ROM or IO devices which you are working. The data I need to transmit or data I need to receive, that is done by using this trans receivers. And here we have a latches where these latches are connected to multiplexed address and data bus. So here what are the how many here we have a latches. So latches, what does it do? Latches are nothing but the storage element. So I need to send my data to the memory location which I need to process via 8086. What I can do is this memory latches will store you the content or the data bits whatever I need to process in this latches, and it acts as a mediator between to store the data between 8086 and the memories and the IOs which are connected. So this is a minimum mode of 8086 which is connected in order to operate in a minimum mode, in order to work with the memory as well as a single IO to my processor. So this is a way our architecture of the minimum mode shows you. Here, How the read signal is done. How the read signal of 8086. When we know how a single instruction in order to execute, it uses how many clock pulses? Is 4 clock pulses. This is the 1 clock pulses. This is second clock pulse. This is third clock pulse. This is 4. This is 5. So whenever I need to work with the processor, I can know which pin is equal to high, which pin is low, and which is active, which is inactive in a particular time periods can be seen in this timing diagram. So this is a timing diagram of a read cycle, where this read cycle includes 4 time periods T1, T2, T3 and T4, where a wait time period is included between T3 and T4. This indicates that if there is no synchronization between one-to-one system, the processor need to wait for some time in order to make the synchronization between the two processes. So first I need to take the data. So in order to take my data, I need to first enable the address. So first address need to enable, then from the address we need to place the data, and then via using a read and write operation signals, we can take the data from the data lines, and we are processing it, and again we are writing and we are placing on the data enable, and then via transmit and receive pin you're sending the data. So all the pins which included this read and write operation, data transmission for read and write operation, includes that each time period at which time period each pin is high, which time period the data is activated, which time period the data is processed, which data at which time period the data is read. This can be seen in this timing diagrams. So first at the first initial time period, address is latched. That is nothing but ALE is enabled, and remaining time periods you need to make it as 0. Next, the multiplexed. What are the multiplexed address and data lines? Are address and status, address and data. So first we need to take the address, then we need to latch the status. So first, whenever the ALE is equal to high, at all the time periods, whenever ALE is high, all the address pins will be equal to high, or it is enabled. So if you see, address and status pins are enabled at T1 time period, and address and data pins pin where address is enabled for T1 time period. Whenever ALE is high, address will be enabled. It may be whatever the multiplexed, it is multiplexed with any status lines or data lines, those will come into consideration. Next, and remaining clock pulses, you can see address and status. First address is enabled, and remaining the status will be enabled for all the time periods. And next, address and data. Address and data, initially at T1 time period, address is enabled, and remaining the data will be enabled. So here, as we are going for only read cycle of an 8086 in a minimum mode, we are having a read signal. RD bar. RD bar indicates that we are reading the data, we are taking the data. So when this pin will be equal to highest, when the data is present on the data bus. So you can see here data is present from T2 to T4. T2 to T4, data is present on the data bus. So when the data is present on the data bus, then only you can access. So that is what RD bar pin is equal to low, and RD bar pin is equal to high initially because it's an active low pin. Whenever it is equal to low, then only it will work. Whenever it is high, it doesn't work. So whenever this address latch enable pin is high, at that time period RD bar is equal to high. And when the data is received in the remaining time periods, then the data pin will be equal to low. Next, DEN bar. What is in DEN bar? Indicates the data enable. Data enable pin indicates you whether the data is enabled or present in the data bus or not. So this is also an active low pin. So DEN bar will be equal to high as first initial time period, and next when the data is present on the data bus, which is red, and then at that moment of time period, that is T2 to T4, this data enable pin will be equal to low. It indicates it is working. Next, DT by R bar. DT by R bar indicates that read cycle indicates you are reading the data. So in order to read the data, we need the pin to receive the data. In order to receive the data, DT by R bar, where receive pin is an active low pin, so you are making it as 0 when the data is present. So when this is low, it means that you are accessing the receiving the data. So this is the read cycle, where whenever you are going for each read or write signals, all these pins are activated automatically in order to show the timing at each time period, which pin is equal to high and which pin is equal to low. And next one is a write operation. If you see, as we have gone through the read operation similar to this is also a timing diagram for write operation of 8086. This timing diagrams also shows you at which time period the read write operation is done, and which time period the address is latched and data is latched, and at which time period the data is transmitted, and at which time period data is enabled. So as we know, for every instruction, in order to execute any data, we need a time periods. So all the time periods will function within 4 time periods, where this includes a wait signal. So at first initial time period, ALE will be equal to high. ALE is equal to high for first time period, and remaining time periods ALE is maintained in the low. So at when ALE is high, then for the address and status pin, address is enabled as first time period, that is A19 to A16, and next time period the ALE signal is low, so it will latch the status pins S3 and S7. Next, and the multiplexed address and data, initially ALE is latched, ALE is high, so address will be latched here, that is the A0 to A15. Next, remaining are data, where after the address is latched, next multiplexed is data. So the data will be enabled in the next remaining clock pulses. So we need to go for write operation. So WR pin will be activated. So WR pin is also an active low pin, where this active low pin indicates when the data is present, then only it needs to work. So this pin is equal to low, and at first ALE pin, this is equal to high. So that is what a write operation is done. Data enable. Data enable, as it ensures when the data is present. When the data is present on the data bus, when you are writing the data. When you are writing the data, then you can see data is working through. So that at that time period, the data enable pin will be equal to low. Then why? Because a data enable is also an active low pin. So whenever it is equal to 0, then only it works. And next one, DT by R bar. DT by R bar shows you whether you are transmitting or receiving the data. Transmitting the data means it shows we are doing writing operation. Whenever you're reading, it means you're receiving operation. So here this pin will be high, and all through the time period, where because already the data is enabled on the data bus, so this overall time period DT by R bar is made as high. So this is what the timing diagram for write operation of 8086 in a minimum mode. Next we'll go for maximum mode. What is a maximum mode? Maximum mode of 8086. Here, what is a maximum mode? as we know, maximum mode indicates that more than one processor you are connecting to 8086. So more than one processor means you're connecting a peripherals. Peripherals, so you can see as it is similar to the register which the maximum mode register. Here we have a clock generator which generates a clock frequency, that is 8284 clock generator, which is having a crystal oscillator, which uses a crystal oscillator in order to generate 8 megahertz, 10 megahertz and 15 megahertz of 8086 frequency on. And as usual, it has a reset pin and it has a ready pin. And if you see, the outputs of clock generator are reset, clock and ready pins. So here this is an 8086 processor. Here my processor is working in maximum mode. Maximum mode means my MN by MX bar should be connected to ground. That is VCC, that is ground, that is nothing but 0 volts. MN by MX bar. MX bar is an active low. So this should be connected to the ground, that is a 0 volts. And here this 8086 has external status pins S0, S1 and S2. These are the output pins for the 8086, which shows you the status, whether you're using a word or byte, or whether you're going for reading the data from the external, or writing the data from the external, or whether you're making as halt, whether you're making a peripheral ready. So this the status of this will be shown by S0, S1 and S2. And these are the multiplexed address and data lines which are connected to the latches, and A16 to A19 are the address pins which are connected to the latches. So here latches are used in order to store the content, where you can transfer the data from the address lines to data lines, from the data lines to the external memory or the peripherals which are connected. And here for the transmission of data, in order to show the direction of the data which is transmitted and receiver, this is shown by using this dir, the direction pin, that you are using a data buffer which is connected with the data enable pin. And here we have a latches which is storage purpose, and here we have a control device 8788, where this 8788 will control the signals according to the operation, whether I go for data enable, or whether I go for DT by R bar, or whether I go for input output read control, input output write control, memory write control, memory read control. So these IO read, IO read control, IO write control, memory write control, and memory read control. Now to generate these control signals, we are using 8788 as a system which is connected to 8086. So this gives you a control signals. These IO read control, IO write control, memory read and memory write are connected according to the whether you are using a peripherals which are IO, and whether you are using a memory. Suppose I am using a memory operation. So what are the pins which are connected from the 8788 are memory related operation. That is, memory write control pin need to connect to the memory, and memory read control should be connected to the memory. And peripheral is nothing but it's an IO device. For this I need to connect IO write control, and IO read control should be connected to the read and write, corresponding read and write pins. So this is a chip select, where chip select gives you whether I need to enable my peripheral pin or not. When you are enabling this pin, then it will function. If you are not enabling this pin, there's no function of the IO which is connected here. So same here. Here also we have a chip select lower and chip select higher, that indicates that you are going for the address bus and data bus, lower data as well as a higher data. So you are going for the read and write signal which are connected from the memory write control and memory read control. This is how external maximum mode of an 8086 can be connected. So this 8086 can be worked by connecting the processor in this fashion by using these controlling signals, by using 8788, by using a latches and a data buffer. So here for this a minimum mode and maximum mode, as we know, uh, we need to know the timing diagrams at which time period the data is enabled and which time period data is disabled. So here the status pins, so S0 and S1 which is given here. These S0 and S pins shows you whether we are working in the IO mode or memory mode. See here, you can see whenever these status pins are 00, it means you are going for interrupt acknowledgement. Whenever this pin is 001, you go for IO read operation. Whenever it is equal to 010, you will go for IO write operation. Whenever it is 011, you will go for halt. And whenever it is 100, you go for opcode fetch. Whenever it is 101, you go for memory read operation, and 110, it means memory write operation, and 111, it gives a passive mode which doesn't work. So these are the different status how the function is assigned to 8288 in order to generate the control signal to function, to give the signals to the IO or the memory. So here, as we have seen for the timing diagrams, how we have assigned the same timing signal is seen here. You can see this T1, T2, T3 and T4 are nothing but the time periods which are required in order to access. Here we can see here the TW signal is not present. Why the TW signal is not present is the TW signal is nothing but a wait signal where it is need to make the synchronization between the external peripheral to the IO. So there is no need of any wait signal for this device whenever you're going in the maximum mode. And ALE pin is made initially high where the status pins will be active initially. The status pins shows you whether you're going for the IO read operation or IO write operation or memory read or memory write operation. So initially what operation I need to do, that should be finalized in before itself so that I can activate my IO device or the memory in order to function. So in order to activate that, you are using a status pins initially which is made as active at first time period when ALE is equal to high. Next, an address and status pins. As we have seen in the previous read and write mode, here also first address and status which is multiplexed will first initialize address bus. Next, it will initialize the status pins. Next, when ALE is equal to high, and next address and data pins, and remaining address and data which are multiplex, the address lines will be activated at the initial time period and data will be initialized at the next time period. And here memory, here we can see if you are working, this can be MRDC, is nothing but memory read control. So you can go for memory read control, or you can also go for IO read. You can go for IO read control. So I have taken example that my processor is working in the memory operation. So this pin can be either IO read control or memory read control. So this memory read control or IO read control will be activated whenever you are having a data. So this will start initially and will end when the data when the data is present. And the next one is DT by R bar. What is DT by R bar? As we have seen, data transmit and receive. And when the data is high, when the data is present, then this pin will be equal to low. So here the data is present because I have read the data in this time period where I have got a data. So if at this time period I have got a data, then at this time period I need to go for the read operation. So next, data enable. So data will be enabled. Here you can see it is not an active bar pin. So here this will be low for this particular time period, and when the data is present, whenever you are getting a data at that last time period, the data pin will be enabled. So this is how the bus controller 8288 generates status signals. But depending upon the status signals, it generates the control signals, IO read control and IO write control, and memory read control and memory write control to work with the processor. And next, and this is nothing but you go for write operation. Write operation, it is also similar to the read operation which we have seen here. It shows the status. So the same status, depending upon these status pins, via bus controller 8288, it will generate the signals of memory read control, memory write control, IO read and IO write control. So here 000, it is nothing but interrupt acknowledgement, and whenever it is 001, it means IO read operation, and 010 IO write operation, 011 halt, and 100 opcode fetch, and 101 memory read, and 110 memory write, and 11 is a pass. So here, if you see the general operation by using a one single cycle, that is nothing but T1, T2, T3 and T4. First, initially we know address should be enabled, so ALE will be equal to high. And next, the status pins. So depending upon the status pins, we need to generate an external control signal, that is memory read operation, memory write operation, and IO read and IO write operation. So in order to generate those control signals, we need to activate S0 to S2 before itself. So depending upon these activation of the signals, the remaining pins will be activated, either the IO or the memory. So here next pin will be address and status. And next address and status, first address will be enabled at this time period, and next the status will be enabled. So here next address and data pins. In address and data pins, first address is multiplexed, so that multiplexed address will be activated first, then the remaining data which you are using, which have been multiplexed. Next, how the status of the pin which is activated at initially will shows you whether you are going for memory write control or IO write control. So this we can use any of the pin, both are active low pins. So this active low pins and memory write control bar, whenever it is equal to 0, then the data is processed by using a memory operations. And here whenever IOWC is nothing but input output write control. So input write also is having an active low pin. So whenever this pin is equal to low, the data which is present at that time period will be accessed. So this is how this memory write control TC and memory IO write control. Similar, you can also go for the read operation also. There also we have memory write control RTC and IO RC. So depending upon the activation of status pins, that signals will be automatically made as high and low according to the status pins. And next you have DT by R bar, where DT by R bar is nothing but you need to transmit the data, so always this pin will be remained as high. And DEN bar, data enable. So data enable bar indicates whenever it is low, then only you can work with the pin. So it is 0 means the data is processed. So these are the different minimum mode and maximum mode which is activated by using the bus controller unit. So when you compare with the minimum mode and maximum mode of 8086, here the circuit diagram which shows you in the minimum mode does not consist of any external bus controller. So this is a minimum, it does not consist of any external bus controller. Where if you go for the maximum mode, in the maximum mode we are using an external bus controller. This bus controller will decide you how many peripherals you have connected and how many peripherals you are working to with the 8086 will be decided according to the signals which are generated. So you are generating the signals by using a bus controller unit, and we are activating the output signal according to the use. So there is no wastage of any time between the accessing of any external peripherals with the devices. So that is a main advantage. And whenever you are going for minimum mode and maximum mode, you always make sure the pin mn by mx bar, where mn by mx bar is whenever it is equal to 0, it means you are working with the maximum mode. Whenever it is equal to VCC, then it is working in the minimum mode MN. So automatically all these latches and the data buffers and also the bus controller will come into consideration with the 8086 in order to connect the more than one peripheral devices. So that is what these are the peripherals where it consists of more than one peripherals can be connected. So how many ever the peripherals are connected to it, depending upon that status lines will be connected. So this is a minimum mode and the maximum mode of 8086 with the timing diagram of read and write operation. Timing analysis is very important in order to know at which point, at which time period the signal is made high and which time period the signal is made low for that particular pin. So for a 40 pin IC which you are taking, for 40 pin IC, each pin will be having a signal to the pin where it will be made as active. So active means you are working with that pin. So the maximum mode and minimum mode is a special advantage for 8086 to connect a single to one peripheral or else one to many peripherals. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.